Hello students, let us continue with the last section of number systems, that is chapter 1 of your textbooks. Today we will be looking at laws of exponents. So in your previous classes you have learned the laws of exponents for natural numbers. So let's say we have a, m and n belonging to the set of natural numbers. Here we have different formulas. Let's see how this works. So we have first of all, here a is the base and m is the exponent. Similarly, a is the base and n is the exponent. So if you are writing any term such as a raised to m or a raised to n, this term is known as the base, okay, and this term is known as the exponent. So we are learning the laws for exponents. Okay. So we have a raised to m into a raised to n. Now you see that the base is the same for both these terms, a raised to m and a raised to n. So this can be further rewritten as a raised to m plus n. Because of the common base, the exponents get added when you have the two terms getting multiplied. Similarly, now see, you have a raised to m which is in brackets and then you have n outside. So m here, if you see, there is a bracket here, which means m will get multiplied with n. So this can be written as a raised to m into n. The dot sign indicates multiplication. Then you have a raised to m upon a raised to n. This term a raised to m is getting divided by the term a raised to n. We notice that both of them have the common base, that is a. So this can be written as a raised to m minus n. If you find difficulties in remembering these terms, just remember that here you have a dash, okay, as the sign of division. But when you take it on top, just put this dash over here instead. Keep the base same, that means keep the numerator same, just add a dash and the second exponent which is n. Similarly for this you have a bracket. Whenever you have brackets, you have learned that you multiply. So m is getting multiplied with n. And finally, you have a raised to m and b raised to n. Now, here the bases are different. Just give me a minute. A raised to m and b raised to m. I'm sorry, this term here was a raised to m and b raised to m. Here the exponents are same but the bases are different, alright. So you can take these two terms, that is the base, combine the two bases, multiply them and take a common exponent. So this is nothing but a into b raised to m. Now let us take a look at certain examples of your textbooks. So here we have 17 raised to 2 into 17 raised to 5. Common base, so how are you going to solve this? This will be 17 raised to 2 plus 5, which is 17 raised to 7. Similarly, you have 5 raised to 2, the whole thing raised to 7. So here 2 is going to get multiplied with 7. So what do we get? We get 5 raised to 2 into 7, which is 5 raised to 14. And then you have 23 raised to 10 and upon 23 raised to 7. So this can be written as 23 raised to 10. There is a dash over here for the fraction. So you take 10 minus 7. This is the easiest method or way to remember it. So 23 raised to 10 minus 7 is 23 raised to 3. Now look at this term. You have 7 raised to 3 and 9 raised to 3. The base are different, right? 7 and 9 are different, but you have common exponents. So this can be written as you club 7 and 9, you multiply 7 with 9 and take a common exponent here. So this is nothing but 7 9s are 63, 63 raised to 3. So we have learned the laws of exponents for positive numbers, that is for natural numbers, where a, m and n are natural numbers. But what if you have negative numbers? We can extend this laws of exponents for negative exponents as well. So here are certain examples, just the same as these but with negative signs in the exponent. So how is this going to work? This is nothing but 17 raised to 2 plus minus 5, correct? So this is 17 raised to 2 minus 5, which is 17 raised to minus 3. Now 17 raised to minus 3 can be written as 1 upon 17 raised to 3. So whenever you have a negative exponent, the base goes down in the denominator and your negative exponent becomes positive. Similarly, you have 5 raised to 2 into 7. So this is nothing but 5 raised to 2 into minus 7, which is 5 raised to 2 into 7s are minus 4, 2 into 7s are 14 and the minus sign, so minus 14. Therefore, you can write this as 1 upon 5 raised to 14. See, the base came down below 1, so it becomes a fraction and the negative exponent becomes positive. And then you have 23 raised to minus 10 and 23 raised to 7. So this becomes negative here. See, we have learned this over here also. 7 is going there in the 23 upon 7 is going in the numerator. That is why the sign of the exponent is changing, which is what we did here as well. So this is 23 raised to minus 17, which can further be written as 1 upon 23 raised to 17. And then finally you have 7 raised to minus 3 and 9 raised to minus 3. Therefore, you take 7 and 9, you multiply them together and the common exponent is minus 3. So this is 63 raised to minus 3, which is nothing but 1 upon 63 raised to 3. So you have seen that in the 8th grade you have learned the laws of exponents for natural numbers, which can now in the 9th standard you are learning that this can be further extended to negative exponents as well. You will see later that these laws of exponents can be extended for rational numbers, but just before I proceed with that, let us look at this new concept. Just hang on, I will erase the board. So we have a new concept here. I have nth root of a, where n is a positive integer and a belongs to the set of real numbers and a is greater than 0. So first of all, you need to understand that this sign is known as radical. When you, by default, when you do not have any number here, it means nth root. I'm sorry, it's square root. If you have 3, it means cube root. If you have something like 4, it is called the fourth root, and so on. So you know what is square root and what is cube root. Suppose if I have 4, so root of 4 is going to be root of 2 into 2. Since it is second root of, square root is nothing but second root, right? So you have to take 2 terms and just take out 1 term here. So this is 2 plus or minus 2. Similarly, if you have 8 and I am saying cube root of 8, this is nothing but 2 into 2 into 2 cube root. Now since here there is 3, I am going to take 3 terms and remove only 1 common. So this is 2. Notice that here it is plus or minus 2, but here it will always be 2, because if you take minus 2, that means it is negative 8, but negative 8 would be a complex number, it is not a real number. I am sorry, the cube root of negative 8 would be a complex number. We will see complex numbers when you go in your 11th grade and so on, but now right now you need to remember that we are considering only positive integers. Even if you have something like 12, square root of 12. Now this can be written as how? 2 into 2 into 3, square root of 12. So here we have the square root, right? So I am going to take 2 outside because there are 2 terms, but 3 is getting multiplied with, there is not one more extra 3. So I will leave this as 2 root 3. Okay, so I hope you have understood what outputs we get when you are taking the nth root. Now nth root of a can also be written as a raised to 1 upon n. We have seen this before also. So if I have root of 2, this can be written as 2 raised to half. If I have cube root of 2, this can be written as 2 raised to 1 upon 3. we are always going to take positive integers over here. 3 is going to be my positive integer, and whatever is there in the under root is also going to be a positive integer. So in short, n is going to be a positive integer and a is also going to be a positive integer. So you have seen this for everything with numerator as 1. What if you have a term like this, 4 raised to 3 upon 2. Now notice that 4 raised to 3 upon 2 can be written as 4 raised to 3 into 1 upon 2. What if I take this as 4 raised to 3 first and upon 2, or this can also be written as 4 raised to 1 upon 2 raised to 3. Let's check the output. This is 4 cube is 64, 64 raised to half, which is nothing but square root of 64, which is 8. Correct? Now let's check for this one. Or this is square root of 4 raised to 3, or 2 raised to 3, which is equal to 8. 2 cube is 8. So you see that when you have something like this, where 4 is the base or any number is the base, and you have an exponent in the form of a fraction where the numerator is not 1, you can write it in this form. Either you are going to take the first term, that is the numerator, and then multiply it with the denominator, okay, or you can take the denominator first with the base and multiply it with the numerator, like this. So in short, what I mean to say is, if you have a term a raised to m upon n, this can be written as nth root of a raised to m, or it can also be written as a raised to m nth root of a raised to m. Okay, so this was about the radicals, where you will have nth root. It could be a square root, cube root, fourth root, fifth root, and so on. But just make sure that a, m, and n here are all positive integers. Having said this, we can extend our laws of exponents to rational numbers as well. So if you have a greater than 0 and p and q are rational numbers, let's see our laws of exponents. A raised to p into a raised to q can be written as a raised to p plus q. Then if you have a raised to p, the whole thing raised to q, it is nothing but a raised to p into q. The dot sign here indicates multiplication. Then if you have a raised to p upon a raised to q, this is nothing but a raised to p minus q. Similarly, the fourth one, if you have a raised to p into b raised to p, it is nothing but, where b is also greater than 0, you have a into b raised to p. So your laws of exponents are applicable not just for positive integers but also for negative exponents as well as rational exponents. Your exponents whether your exponents are rational numbers. So we will take a look at solved examples in your textbook. Before that, I will just quickly erase the board. So this is going to be solved example 21 on page 26. Let's take a look at the first one. You have 2 raised to 2 upon 3 into 2 raised to 1 upon 3. The second one is 3 raised to 1 upon 5, the whole thing raised to 4. Then you have 7 raised to 1 upon 5 upon 7 raised to 1 upon 3, and finally you have 13 raised to 1 upon 5 into 17 raised to 1 upon 5. So let us solve this one after the other. Now this is nothing but a raised to m and a raised to n. So this will be equal to 2 raised to 2 upon 3 and 2 raised to 1 upon 3, they both are getting multiplied. So you have a common base, therefore you are just going to take the common base and add the exponent. So this is 2 raised to 2 upon 3 plus 1 upon 3. Common denominators here, so the LCM is going to be 3 and you can directly add your numerators. So this is going to be 2 raised to 3 upon 3, which is 2 raised to 1, which is 2. Let's move on to the next one. You have 3 raised to 1 upon 5, the whole thing raised to 4. So here 1 upon 5 is going to get multiplied with 4 and the base will remain the same. So this is nothing but 3 raised to 4 upon 5. Now the third one, I have it in the form of a fraction where both my base are going to be same. So I'll just take 7, 1 upon 5 minus 1 upon 3. Now you can't leave your sum like this, you will have to solve this further. So I'm going to solve these exponents. How? Take the LCM of 5 and 3. We know that the LCM of 5 and 3 is 15. So I'm going to multiply 5 with 3 to get 15, and so with the numerator of 5, and this with 5 and this with 5. So what do I eventually get? 7 raised to 15 upon 3 minus 5, which is 7 raised to minus 2 upon 15. So if you want, you can solve this further. This is nothing but 7 raised to 1 upon 7 raised to 2 upon 15. Why 1 upon? Because this is a negative exponent. That is why I have got my term 7 raised to 2 upon 15 in the denominator, which is why my exponent now becomes positive here. Okay, I will continue this sum here. So this is 13 raised to 1 upon 5 and 17 raised to 1 upon 5. Now the exponents are the same, but we have different terms in the base. So I am going to multiply the base together. So 13 into 17 raised to 1 upon 5. So 13 into 17 is 7 3s are 21, 7 1s are 7, 8, 9, 13. So 1, 2 and 2. So this is 221 raised to 1 upon 5. So let us box our answers now. So you can take either this or this, that's why I am boxing both of these. Or, so with this we have completed the solve examples of the laws of exponents. We will take a look at the last exercise of your chapter in the next class, which is exercise 1.6. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.